I'm here in sunny Ann Arbor, Michigan to talk with May Mobility about their autonomous driving solution that they're installing in these Toyota Sienna minivans. It's not just technology for technology's sake, they're using it in ways that really benefit society. Let's check them out.
So this is our May vehicle. The base platform is a Sienna, so from our partners at Toyota. To the Sienna, we then add our Autonomy Development Kit, our ADK. So our ADK consists of a set of sensors. On the top here we see there's a Velodyne LiDAR. There are radars in each of these two kind of ears on the side. And then there are cameras that look out in three directions. So this is our core sensing platform focused mostly in front of us, although the LiDAR does see behind us as well. And then to fill in blind spots around the vehicle, we have a LiDAR together with camera. Here on the left, we have one in the front. This is really for low objects, for safety critical braking. Yeah, and there's a radar here as well. And then over here we have the same thing as we have on the other side. Finally, behind the vehicle, we have radar again, pointing back into the side, and then a rear-facing LiDAR and camera. So altogether, this gives us a 360-degree view with LiDAR, radar, and camera. And those are fused together in the computational part, which I can show you real quick. It sits here. So on this vehicle, the compute sits under this passenger seat. And so we have a computer there, as well as network switches and power that then processes all that data and then makes decisions about how the car is going to drive. It's the third major vehicle. We started out with a GEM, and then we followed that up with a Lexus that we retrofit. Mm-hmm. And then this is the first vehicle that we've worked with an OEM partner to kind of design in the vehicle control interface. So, and then this is the second generation of that.
Before we hit the road, a key feature to understand is May Mobility's multi-policy decision-making, and engineers love acronyms, so they call it MPDM. A good visual example is where an autonomous vehicle needs to make a sharp left turn. It can see a cyclist approaching from the other way with a faster traveling car behind it. Each could choose to make a different decision. The car could try to overtake the cyclist before the curve. The cyclist could take the turn wide. The onboard computer simulates multiple scenarios in a fraction of a second. It scores multiple possible outcomes for safety and comfort based on its own actions. It determines that its best possible action is to take the turn wide and to the right. A good human driver would probably do the same based on years of experience behind the wheel.
This display shows what the car can see as well as what it's doing. These are just the 3D bounding boxes of all the vehicles it sees. You'll see the path it wants to take. When we start driving, you'll see another path kind of ease out from there, and it shows where the vehicle's predicting it's going to be over time. I think what's especially interesting is this piece over here. Mm-hmm. So when we start driving, that is going to flash different colors and on each of these icons. And what the system is doing is it's showing you kind of what it's thinking. Each of these icons is a simplification of some of the actions that it's thinking of doing. So anything up here is it's thinking about going forward at different speeds. This is kind of coasting. And then these are lateral movements, thinking of shifting to the left, to the right, or recentering. And these are stopping movements to either slow or stop. And what the system is doing, and this is what's kind of unique in our system, is while it's driving, it will take everything around it. It'll take these different actions that it can do. It will simulate them much faster than real time and basically play out the different scenarios that could happen in the next 8 seconds. And then it will pick the thing that looks safest and gets us somewhere. Pedestrians and other vulnerable road users like bicycles, scooters will show up as orange.
With AI, obviously, is such a huge topic, and it's led to even people like me using terms that I'm not totally familiar with, such as like training data, neural networks. But so do you still do some of that, but it's less important to the function of your vehicle?
Yeah, we still do it, especially in our perception system, also in our predictive system. and we continue to explore other ways. What it does is it allows you to take all the drive data you have and optimize your driving experience based on what you've seen in the past. What it doesn't do as well is predict what's going to happen now, right? If you see something new, a new situation, an edge case people call it, it might not function correctly there. And so what people will tend to do is they just say, well, let's drive more, let's get more data, let's process more data. And it does get better when you do that, but it becomes like a point of diminishing returns at some point. So our solution to it is, yeah, let's gather that data, let's learn a model, but instead of just saying every time there's a problem, let's gather more data, what we do is we say our models are going to be imperfect. So when we're uncertain, let's simulate the different things that could happen while we're driving at the moment we need to know about them in a narrow context, and then make the decision based on what that simulation tells us. And so it allows us to still use these models, but to not have to perfect them to the same level of precision and accuracy, because if they're a little bit off here or there, the simulation at the last second is going to catch their mistakes. Like if we're going to hit something, or if something's moving in a way that we aren't sure about, we're going to simulate the multiple things it could do.
At this point, I'm going to let the drive play out in segments and pause to provide my comments based on the display for the rear passenger and what's happening out front. Here you can see a cyclist coming the other way. The system shows it to the passengers as an orange box. Also note that this road and many others in Ann Arbor have bike lanes. Those are indicated on the map as a road different than the one it can drive on. Now, as we get to the intersection, you can see a large purple box pass by. That's the bus. The intersections clearly show the crosswalks for pedestrians. May Mobility said they do not rely on a high-definition map. That kind of map gathers LiDAR data for the operational domain it plans to travel in, but they do utilize some data attributes from a digital map, likely to know things like which intersections are controlled by a stoplight, the number of lanes on each road, as well as data needed for navigation like road names and speed limits. This next encounter is very interesting and gives a glimpse into their multi-policy decision-making. We're approaching an intersection. You can see the light is red, so the car is slowing down. As we get closer, it turns green, and the van gradually starts to speed up until it detects pedestrians walking towards the intersection. You can see them off to the right. They keep walking towards the intersection. Somewhere in the many, many scenarios is one where they walk right into the intersection, not paying attention. So the van proceeds cautiously until it sees that they are indeed slowing down before the road. Then it accelerates. It was being cautious, and that's a good thing. I mentioned in the intro that May Mobility is deploying their technology in ways that help people. Currently, they're operating in the college towns of Ann Arbor and Arlington. Many of their vans are ADA compliant, able to accommodate wheelchair passengers. In rural Grand Rapids, Minnesota, they supplement the transportation options for that community. From the retirement community of Sun City, Arizona, to the active streets of Detroit, they work with city planners to best serve the local community. It's road construction season in Michigan. Here's a temporary construction zone. I looked on Google and Apple Maps. Neither of them flagged this as a construction zone. Workers alternatively waved on cars to use the one lane available.
This is going to be interesting. One thing we don't do right now is the system does not try to detect these hand signs. So if they were to block the road, we will have to manually drive through it right now. And it's being very, so kind of what it does is to drive through narrow spaces, it wants to do it very slowly because it's willing to get close to people if it drives real slow. So you see it kind of slow down until it found the speed that it's comfortable driving by that person, and then it's able to ease through.
In our case, we were allowed to pass and just follow the vehicle ahead of us. Had the worker flipped the temporary sign to stop, it would have likely required intervention by the safety driver. May Mobility vehicles are operating at SAE Level 4 of driving automation with a safety driver, except for one market where they're going without that. The safety driver can also help people into and out of the van as necessary. It's a Level 4 because the AV is limited to a specific area of operation. That's its operational design domain, or ODD. If you'd like a better explanation of the levels of driving automation, I did a video on that. You should check it out. Should one of their vehicles encounter a problem, there are two ways it can handle it. First, the safety driver can take over. To transition away from this, all vehicles are monitored remotely, and the teleassist can intervene as required. They set up a demonstration of this behind the building. If the AV sees construction cones blocking the road, it's not allowed to just try and figure it out. It phones one of its human friends for help. You can see on the rear passenger display a message that an operator is assisting with navigation. Then you'll see a green line indicating the path that the human has instructed the vehicle to follow. Overall, how was the driving? Let me put it this way. I have kids. I was the one who nervously sat in the passenger seat as they earn their hours for their learner's permit. May Mobility drives much better than my kids did. Sorry about that. Steering was generally smooth, and unlike meat-based drivers, it doesn't go over the speed limit, and it's cautious, and that's a good thing. Now let's go inside and see how May Mobility autonomous vehicles are put together.
Our production process is largely broken down into three major steps. The first one being the configuration. That is all of our sensors, all of the off-the-shelf components becoming May-specific items. Integration, which is the mechanical and electrical work that happens on the vehicle at our contract manufacturing facility in Detroit to integrate the sensors to the Sienna Autonomos platform. And lastly, commissioning, which includes sensor calibration, updates, and readying for launch to a customer site. This is our sensor configuration lab. In this space, we do very little these days, which is great. We are interested and working towards scale, which means a lot of our sensors and components, network switches that come off the shelf, are now configured to May Mobility specifications at the vendor level. We order a camera, it comes with our firmware installed. We order an ECU, that shows up with our firmware installed. This allows us to work towards a PO direct model that will be efficient, regardless of the scale at which we're operating. So when we're done with configuration, everything comes to our quality department. This team is responsible for checking all of the parts that come from our North American vendors and industry partners. We run inspections as well as our PPAP process to ensure we get exactly what we need for every vehicle. We also have a bench station where we're able to install all of our sensors on a bench and ensure that they're operating nominally. So we check their health level and that each sensor can be communicated with as an in-process check before this ADK will ship to our manufacturing line in Detroit. So all of our parts will be controlled by our inventory management team. This team is sort of my favorite at May because we have some truly wonderful inventory control associates. Ruka and Zama are our experts that make sure no parts go missing anytime throughout our inventory management process. Oh. So our favorite two maniacs. Here, we're going to build two vehicles. We have a standard Sienna that you took a demo ride in today, and we also have a wheelchair accessible Sienna that's been upfit by our partners at Braun. We're one of the only AV companies in North America offering wheelchair accessible services to the public today. Ensuring autonomous vehicles are developed in such a way that it advances equity for all people is a key pillar of what we do at May Mobility. We're immensely proud of this effort in our partnerships. Our manufacturing facility in Metro Detroit, they perform all of the body modifications. So they cut holes in the fenders to mount sensors. They do the assembly and plug in all of the components at their facility. Their work includes 5 LiDARs. Here you've got the Ouster short-range LiDAR, as well as camera pairing. We have a total of 5 LiDARs, 7 exterior cameras, and 5 radars. The May ADK, or Autonomous Driving Kit, consists of all of the sensors you see on the exterior, as well as the sensors and displays on the interior for our cabin monitoring system. We've removed the front passenger seat and installed the ADK there. This houses our main compute ECU, as well as our power module for redundant power, and any interface boxes to communicate with our network and the sensor suite across the entire vehicle. It is all housed in that location.
They didn't want to show the processing unit used to drive the vehicle. They did claim that it's not as power hungry a unit as some other autonomous vehicles. The Toyota minivan they use is a hybrid, not a full electric, so there is no obvious massive battery powering the system.
Our wheelchair accessible Sienna is upfit by our partners at Braun Ability, and this is a commercial mobility solution that's been deployed in other regions of the US already. So here you can see the entry ramp for our wheelchair occupant. You can see our Q-Straint wheelchair securement straps, both forward and an in-floor puck mounting system. And you can also see this bit of cleverness. So we've been able to preserve the second row occupants, which means we have room for a wheelchair occupant and their guests, their company. Too often in dedicated paratransit, your wheelchair rider needs to be in their own vehicle and everyone else comes in a second vehicle. It's inefficient. This allows us to serve a variety of needs. If we don't have a wheelchair occupant, this jump seat folds down and we can carry 4 ambulatory passengers without a wheelchair occupant, or 2 ambulatory passengers with a wheelchair occupant. The third stage of our process is vehicle commissioning. In the commissioning process, we bring the vehicle online, calibrate the sensors, and install any necessary software firmware updates to it. So that's the primary work that happens in this space. Here you'll see our work on fixed target calibration to optimize and improve our calibration processes for development at scale. So these 2D codes are used to map our sensors, particularly the cameras, to LiDARs. This field of targets is designed for a post-production calibration. Essentially all of our sensors on all sides of the vehicle calibrated simultaneously. That's what this station affords us, with the numerous targets positioned in specific locations and angles. These are actually 2 of our newest vehicles for our 5.2 production program. These are fresh off the line in our start of production, and these will be used in some exciting announcements later in the year that you'll just have to stay tuned to capture.
That was a lot of great information from a company that seems like a cool place to work at. I'd like to thank May Mobility for providing this peek into their advanced technology. Thank you, Jacob, Anaru, Eric, Ruka, and her buddies Zuma and Oakley. For more information about May Mobility and the areas that they serve, check out their website. They also have some great videos highlighting the people who are benefiting from this advanced technology. And that's the way it should be.